Imagine you're building a sophisticated React application where different users, admins, editors, viewers, need tailored interfaces. As your app grows, hard coding permissions or sprinkling role checks everywhere quickly leads to a tangled, fragile code base. You risk duplicated logic, maintenance nightmares, and accidental security holes. But what if you could elegantly add role-based UI features without bloating your project with yet another third-party library? Today, you'll unlock the power of the JavaScript Decorator Pattern, a design strategy that lets you flexibly attach role-based behaviors to any React component, keeping your code modular, reusable, and easy to test. By the end of this session, you'll know how to architect scalable, maintainable permission systems directly in your React app, using only built-in JavaScript and React features. You'll see how to isolate role logic from core UI components, avoid prop drilling, and ensure your UI adapts instantly as user roles change. Whether you're building admin dashboards, multi-tenant SaaS platforms, or rolling out feature flags for beta testers, this approach will streamline your workflow, reduce bugs, and future-proof your project. Stay tuned for step-by-step guidance and real-world best practices. And if you find value here, subscribe to our channel for ongoing expert tutorials that keep you ahead with the latest patterns and practical React strategies. The application loads, displaying the dashboard as it would appear to a user with the default viewer role. The interface shows only the features accessible to viewers, with restricted elements such as admin controls, editor tools, beta features, and support tools absent from the UI. The dashboard is scrolled to its lower sections, allowing observation of all available content for the viewer role. Next, the role is switched to admin using the role switcher interface. The dashboard updates and features exclusive to administrators become visible. These include the Manage Users button, admin-only panels, and any editor, beta, or support tools also accessible to admins. The dashboard is scrolled from the top, giving a thorough view of each section and the newly revealed admin features. The admin-only UI elements stand out in the interface, confirming their restricted availability. The role is then changed to Editor. The dashboard refreshes to reflect the permissions of an editor. Admin features such as the Manage Users button and beta or support tools disappear, while editor-specific tools and panels are now visible. Scrolling through the dashboard reveals only those features that are meant for editors, highlighting the absence of admin and other restricted content. Switching to the beta tester role, the dashboard updates to display the experimental or beta features. These components, like a special beta feature panel, appear in the UI, while admin, editor, and support-specific features remain hidden. The dashboard is scrolled to the relevant section, emphasizing the presence of the beta feature and the appropriate restriction of other features. The role is then set to Support. The interface updates, showing only the tools and panels available to support users. Support features become visible, while admin, editor, and beta tester specific UI elements remain concealed. Scrolling through the dashboard focuses on the support section, confirming correct role-based visibility. Finally, the role is switched back to Viewer. The dashboard returns to its original state, showing only the features available to general viewers. A scroll to the bottom confirms the restricted features have been removed, and only viewer-permitted content remains visible. The demonstration concludes, having illustrated the dynamic appearance and disappearance of UI features based on the active user role, all managed without any external libraries and entirely through the decorator pattern in React. Let's examine the main application file, which composes the role-based UI using the decorator pattern in React. This file integrates the role provider context, a role switcher UI, and the dashboard component, demonstrating seamless role-based feature toggling without third-party libraries. The app component is wrapped in the role provider, which supplies the current user role and a function to switch roles. The role switcher component renders buttons for each available role. Clicking one updates the current role in context. Below the switcher, the dashboard composes UI elements that are decorated for role-based access. This structure keeps the authorization logic outside of core UI components, ensuring maintainability and modularity across the application. The role context module establishes the foundation for role-based access in the application. It defines a list of valid roles, creates a React context to hold the current role and a function to change it, and exports both the context provider and a custom hook for consuming the context. The role provider manages the current role in local state. The switch role function safely updates the role only if it matches one of the predefined valid roles. All components needing to access or check the user role consume this context, ensuring a single source of truth for authorization throughout the UI. The with role decorator is a higher order component, HOC, that enforces role-based access to any wrapped component. It accepts one or more allowed roles, normalizes them to an array, and checks the current user's role from context. If the user has an allowed role, it renders the wrapped component. Otherwise, it renders nothing. This pattern enables clean, modular authorization logic and can be composed with other decorators for multifaceted UI enhancements. The dashboard component demonstrates practical usage of the with role decorator. It imports two UI elements, Manage Users button and Feature Flag component. Each is wrapped with role, specifying which roles are authorized to see them. The Admin Only Manage Users button is only visible to users with the admin role. The beta tester feature is visible to beta tester and admin roles. By decorating components at the usage site rather than embedding role logic inside them, the codebase remains clean and highly maintainable. This example shows the Manage Users button component. Its implementation is intentionally simple and role agnostic. It only renders a button labeled Manage Users. All authorization logic is handled externally via decorators, keeping the component clean, reusable, and easy to test. The feature flag component is a visual indicator for a beta feature. It displays a message and emoji, but includes no embedded access logic. It will only render for authorized roles due to the decorator applied in the dashboard component. The application entry point mounts the app component onto the DOM root. This standard React entry ensures the entire role-based UI and context are initialized for the user. This test module validates the behavior of the with role decorator using React testing library and Jest. It defines a simple test component, wraps it with the decorator, and uses a test wrapper to set the initial role in context. Two test cases verify that the component renders for the admin role, but not for the viewer role. This ensures the decorator correctly restricts access based on role context. The package.json file defines the project's metadata, dependencies, and scripts. Only React, React DOM, and testing libraries are included. No third-party role or permission libraries, demonstrating the self-sufficiency of the decorator pattern approach. Imagine building a skyscraper. Every floor must be constructed with a clear purpose, yet the blueprint needs to support adding new features, like balconies or safety rails, without tearing down the existing structure. In software development, the decorator pattern serves this architectural need. It's a design strategy that lets you add new behaviors to individual components, dynamically and with minimal disruption. Rather than embedding every possible option inside each component, decorators act like modular add-ons, wrapping core functionality with optional enhancements. In JavaScript, and especially in React, this means using higher-order functions or higher-order components, HOCs, to wrap UI elements, granting them extra capabilities, like role-based access, without altering the original logic. For example, consider a basic delete button. Rather than stuffing user role checks inside the button, a decorator can wrap it and only render it if the user has the right role. This separation keeps components simple and reusable, much like how a balcony can be attached or omitted from a floor plan without affecting the inner rooms. The pattern's power lies in its ability to keep core components clean and focused, while letting you build a scalable, maintainable system of optional features that can be composed, swapped, or extended as your application grows. Let's explore the challenge of user permissions in complex React applications. Picture a busy office where only certain employees can access the server room, others can use the printer, and a few have keys to the supply closet. The office manager needs a system for granting or denying physical access based on roles, without duplicating the lock mechanism for every door. Similarly, in a React app, different UI features, such as admin dashboards, edit buttons, or beta components, should only be accessible to users with the right roles. Hard coding these checks inside each component is like installing a unique lock for every door. It's messy, repetitive, and difficult to update if roles change. The decorator pattern, when applied as a higher order component, provides a central keyring, a reusable function that wraps any component, checks the user's role, and decides whether to render the component. This approach keeps permission logic isolated in one place, makes the UI highly flexible, and prevents code duplication. The result is an application where adjusting access policies is as simple as updating the decorator, not rewriting dozens of components, ensuring both security and maintainability as the team and the codebase grows. Consider the difference between inheritance and composition in software design. Inheritance is like creating a new type of employee by extending an employee class, say an admin employee. But every time you need a new combination of abilities, you're forced to create another subclass. This quickly leads to a tangled hierarchy. The decorator pattern, by contrast, is about composition. It allows you to start with a basic component, such as a button, and wrap it with decorators, like role checks, logging, or analytics, without modifying the button itself or creating new subclasses. This composition over inheritance philosophy aligns perfectly with React's component model. You can create a with role decorator that wraps any UI piece and applies role-based logic, then combine it with other decorators as needed. For example, a with role decorator can be chained with a with logging decorator to create a button that is both restricted to admins and logs every click. This modular approach fosters code reuse, simplifies testing, and makes the UI more adaptable to changing requirements. Just as you can equip any employee with a keycard, alarm code, or parking pass without altering their core job description. Let's examine how the decorator pattern enhances testability and maintainability in a large React application. In real-world projects, requirements evolve, new roles emerge, permissions shift, and features are added or removed. If role-based logic is scattered throughout UI components, updates become error-prone and hard to track, increasing the risk of security holes or broken features. The decorator pattern centralizes this logic. By having a dedicated decorator, such as a with role higher order component, testing role-based access becomes straightforward. You can unit test the decorator in isolation, ensuring it renders its children only for allowed roles. Integration tests can focus on the UI's behavior for different user roles, with full confidence that the core components remain untouched. When a new role is introduced, or an existing one changes, the update happens in the decorator, not across dozens of files. This approach not only reduces bugs and simplifies code review, but also streamlines onboarding for new developers, who can quickly understand where access control resides. Ultimately, the decorator pattern builds a robust safety net around role-based UI, allowing teams to adapt quickly to business changes without compromising code quality or security. Comparing the decorator pattern to third-party libraries for role-based UI highlights a crucial trade-off between control and convenience. Libraries often provide out-of-the-box solutions for permissions and access control, but at the cost of adding dependencies, increasing bundle size, and sometimes constraining the way you organize your code. The decorator pattern, implemented with native JavaScript and React features, gives you fine-grained control over authorization logic and UI behavior without relying on external packages. This reduces your app's attack surface, streamlines audits, and makes it easier to customize the system for unique business needs. Moreover, avoiding external dependencies means you're not tied to a library's update cycle or risk sudden breaking changes. In scenarios where maximum flexibility, security, or minimal footprint are priorities, the decorator pattern stands out as a preferred choice. It empowers teams to craft bespoke, maintainable solutions tailored to their exact requirements, ensuring the UI remains both agile and robust as the project evolves. Now you've seen exactly how the JavaScript decorator pattern can supercharge your React applications with flexible, maintainable user role-based UI without the baggage of extra libraries. By applying these patterns, your codebase becomes cleaner, easier to test, and ready for enterprise-level scale. Imagine rolling out new features or permissions with just a simple, reusable decorator, saving you hours of refactoring and endless bug hunts. If you're ready to unlock more strategies that instantly level up your day-to-day React skills, make sure you subscribe. Each new lesson is packed with practical, real-world examples designed so you can apply what you learn immediately. Dive deeper, build smarter, and stay ahead of the curve. Your future self will thank you.